Yeah. For those of you that wanna know what we're all about, it's like this, y'all. This is 10% luck, 20% skill, 15% concentrated power of will, 5% pleasure, 50% pain, and 100% reason to remember the name. He doesn't need his name up in lights, he just wants to be heard. Whether it's the beat of the mic, he feels so unlike everybody else, alone, in spite of the fact that some people still think that they know. But no, he knows the code. It's not about the salary, it's all about reality and making some noise, making a story, making sure.
There you go, man.
Hey, man. Hey, good practice today, man.
Yeah, dude, it was very fun.
Yeah, you were really working out there.
Yeah. Are you excited for the game?
Yeah, bro. I'm excited for the state championship. It's on Saturday. I can't believe it, bro.
Dude, we gotta win this.
Yeah, you want to hang out this weekend?
Dude, I'm way down. Let's do it.
Yeah, dude. What's this?
Dude, do the test?
I think I have a pre-calc test, dude. I gotta study for this. You know what? I actually can't hang out this weekend.
Hey, that's fine. Hey, make sure you get that done.
No, I gotta pass this or else I can't play in the state championship.
I got you. Hey, Dwight, come here. Who's Dwight? It's a friend.
What's the problem here? Who are you?
Dwight Troop, assistant district manager.
Can you help me with this? I don't know how to do pre-calculus. Like, that's not my thing, man. Basketball's my thing.
Well, basketball is your thing. The world is lucky because your IQ is an insult to humanity.
Man, shoot.
I can help you with this. Follow me.
Wait a minute. Hold on here. This is my house.
Yeah. This would be the best place to teach you. You know, it's a familiar environment.
Oh, like a psychology perspective. Gotcha.
There you go. All right. So I see you're struggling with 5-point graphs, right?
Yeah.
That would be a great strength of mine.
Oh, really?
Yeah. So for an equation here, what you'll have is you have y equals, this will just be a sample equation. This could change from time to time.
Sure. Yeah.
Y equals 3 sine 1/2. Then you got parentheses here, right? And inside those parentheses, you got theta minus 25 pi over 18.
Well, like pie, like something that you eat, right?
No.
So okay.
I understand the need for calories. You're an athlete.
Yeah.
So
definitely burn those calories
burn those
on
calories.
that grind. Yeah.
But this pi is different. This pi measures a circle. So, circle.
Yeah, I got you. Yeah.
Yes.
The radius. Yeah, like a unit circle. Yeah.
Yes. So you got it, right?
Yeah, I got that. Yeah. Sure.
Okay.
Yeah.
Good. So, and then this last part here is plus 4. So, what this means is our starting point is going to be plus 25 pi over 18.
Wait, why does the sign switch?
Sign switch? Sign switch is, you know, I'm not sure why they made it this way, but they made it so that when they made the rule, they made it so that what is in here, its sign will switch when it comes out.
Oh, okay.
Kind of weird. You just have to remember it.
Oh, gotcha.
Yeah. But then the outside, you don't have to switch the sign. It'll remain positive. It's positive out here.
So you're saying opposite of the first, same as the second?
Yes, I am.
Oh, I remember that now. Thank you. Okay, I remember that. Okay.
Well,
Opposite of the first, same as the second. Okay.
all right. So that means first point would be 25 pi over 18, comma 4.
Okay.
And
I see
then,
where you're getting that from. Okay.
so this is a 5-point graph.
Yeah,
Right?
5 points.
Yeah,
like
5 points.
that's a 3-pointer and a 2-pointer. Yeah.
So
5
since
points.
this is sine graph, what's first going to do, since this one, it doesn't have negative out front, right? So it's positive. So that means it's going to go up first before going down and then coming up again. So that means you're going to have a starting point, you're going to have a high point, you're going to have a midpoint, you're going to have a low point, you're going to have an end point. Now what you know now is that the y value, which is the 4, the starting point, is going to be the same for the midpoint and for the end point. Zach!
What? End point, midpoint, start point.
Okay.
Yeah.
I think.
I was paying attention. I assure you I was paying attention.
Okay. I think there's some progress here. All right. So
how do you even solve one of these things from like the equations? Like, walk me through the steps.
well, what exactly do you mean? Do you mean from these equations?
Yeah. How do you make a 5-point graph? Like, how do you do that?
Okay. So you got your starting point already. You know how to get that.
Yeah. The opposite of the first, same as second. Yeah.
Yes. All right. So next thing you want to do is you want to find your period. So the period is period. Just think of it like a basketball game.
Okay,
basketball game.
like at 4 quarters, like a 4-quarter period.
4-quarter period. Yeah. So it's a bit the same, except for this will be like a 5, whatever quarters is for fifths, 5/5 period.
Okay.
Yeah.
Yeah. Gotcha.
So what you'll have here is to find that what you want is 2 pi over 1/2, which is your b value over here, right? And what you'll get from that is 4 pi.
Mm-hmm. Gotcha.
So that'll be the length from the start point to the end point. So what you got to do is you got to take 4 pi, you got to add it to 25 pi over 18.
Oh, so then you get the next point, right?
No, not the next
point,
but the end point.
the end point. Okay.
Yeah,
Okay.
So now you'll have first point, you'll have the last point.
Gotcha. All right.
So your last point will be 97 pi over 18, comma 4. And then what you got to do from there is you got to take the length between these two, which is 4 pi, divide that.
The end point. Okay.
Yeah,
Okay.
So now you'll have first point, you'll have the last point.
Gotcha. All right.
So your last point will be 97 pi over 18, comma 4. And then what you got to do from there is you got to take the length between these two, which is 4 pi, divide that in half, right? So now you have 2 pi. And there's a couple of ways you can do this. The way I prefer is take first point, and here's 25 pi over 18, and add that half of the period, which is 2 pi, to that number. And what you'll get is 61 pi over 18. So then that'll be your midpoint.
Wait. I think I remember my teacher explaining me, like it's called like half-C fractions.
I think so.
Half-C
I think
fractions.
That sounds correct.
So like half-C, like half.
Half.
Gotcha. Okay. Got it.
All right. So then half-C fractions, like you said, are going to be important for the rest of this graph. What you need now is you need to find the high point, and the low point, like so. So this high point, you'll notice the y value is going to change. And the y value is going to change by however many.
Oh, I see.
Yes.
Because you add this value, you add the k value to the a value.
Yes, that
And
is
then
correct.
if it's going down, then you subtract the k value from the a value.
The other way around. You subtract the a value from the k value.
Wait, are you sure?
Positive.
Positive.
Yes.
Okay. Gotcha.
All right. So that means for your high point, your y will be 7. For your low point, your y will be 1.
Okay.
Yeah. And now you just need to find the x. So remember those half-C fractions? You need to make it. So this is 2 pi between the starting point and midpoint. So this point in the middle, that'll just be 1 pi away from the starting point, 1 pi away from the midpoint. So you can do it either way. You can add it to the, you can add 1 pi to the starting point. You can subtract 1 pi to the midpoint from the midpoint.
Gotcha.
Yes, but either way, your answer will be the same. Be 43 pi over 18.
Okay, I get it. Okay.
So
5-point graphing. That's pretty easy. You just do the high point. You do the starting point, the midpoint, the end point, and then you do the half-C fractions, all from that equation, right? Correct? Does that sound about right?
that sounds about right.
All right. You know what? Another topic that I don't know if you could teach me about this, but another topic that I'm struggling with is I don't even know what the name of it's called. It's called
Let's check your book here.
oh, okay. I think it's God, it's on the tip of my tongue. Let's see. I think it's trig identities. That's it. Trig identities. Do you have any idea about that?
Nope. I'm getting out of here.
Do you have a guy that could help me out with some of the series?
Yeah, I do. Sorry about not helping you out with that.
Oh, it's all good, man.
Yeah. But we can go to the basketball court and do it right now if you want. I got a guy waiting there for you.
Wait, is this the guy that goes to Stanford?
Yeah, it does. Yeah.
Oh, okay.
Let's go.
Visit!
Man.
What's up, dude? Are you
So,
the guy that
yeah.
Austin sent me?
Yeah, Austin Jenkins.
Yeah, whatever his name is. The guy with the afro, right?
Yeah.
Oh, okay.
Yeah. So you need help with sigma notation, right?
Yeah, that sounds about right.
Some series and all that stuff.
Yeah.
All right. So there's 4 different parts of that. So
Okay.
I'm just gonna help you with all of that.
All right.
So you got infinite geometric, finite geometric, infinite arithmetic, and finite arithmetic.
Okay.
So let's go with the easiest part, infinite arithmetic.
Okay.
So with that one, the equation for that is actually it's a simple line equation, so like
Yeah.
y equals mx plus b. And to find out the sum of it, you take the m value, the value in front of the variable.
Right.
If it's positive, answers positive infinity. If
Okay.
it's negative, answers negative infinity.
Oh, gotcha.
Real simple, real easy stuff.
Right.
Probably won't even be quiz on that. It's so easy.
Oh, okay.
So then there's finite arithmetic, which is a bit more different. So basically that's when there's a starting term and an end term, and you have to find all the terms in between and add them together.
Okay.
So there's a simple equation you can do that, which is the equation, it's, to call it out, it's a times first term plus the second term all over 2.
Oh, okay. Okay. Yeah.
So
I'm
the
understanding.
a, that's the number of terms, which is to find that you take the value up above the sigma notation, which is like that thing that goes like that.
Yeah.
that, right?
It kind of looks like a Z,
Yeah.
like in my name. Yeah.
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 And then you take the thing that's below it, you subtract the one below the sigma notation from the one on top, and add 1. And there's your number of terms in the actual sum.
Okay.
And then to find the first term, you take the one below, put it through the equation. And to find the last term, you take the one on top and put it through the equation.
Okay.
And then you just divide all that by 2. And there you go. That's
Oh.
finite arithmetic.
Okay.
Real simple, just a quick equation. You gotta remember the parts of it.
Yeah. Okay.
And then for geometric, this one's a little bit trickier. You know what an exponential function is, though, right?
Mhm.
Yeah,
Yeah.
it's the
It kind of
worst.
goes like this.
Yeah, which raised to a variable.
Well, that was a hyperbola, but maybe I got it backwards. That's okay.
But it's the one where it's a value raised to the variable, so it goes forever up infinitely. But for this one, to find the finite, similar to the arithmetic, if the value being raised to the variable is greater than 1.
Okay.
It's the exact same thing if the value being raised to the variable is greater than 1.
Okay.
Negative, negative infinity, positive, positive.
All right.
But that value can be less than 1. And when that happens, what you're going to want to do is you're going to want to use another equation, which is, this time it's a over 1 minus r.
Okay.
So you already know what a is. Actually, for geometric, it's a bit different. For geometric, a is the value in front of the value being raised to the variable.
So like if I'm posting up, it's like the guy that's in front, right? The guy
Yeah.
that's in front. So then I can turn around and jump shot.
When
Yeah.
y equals, then that value a times the multiplier to the exponent.
Oh, okay.
Yeah.
Perfect.
So you take that value that's in front of the multiplier, put it above 1 minus r. And r is just the multiplier.
Yeah.
So you take the first value over 1 minus the multiplier. And it's real simple like that.
Okay.
Yeah, you can even use that if the value is greater than 1, I believe.
Yeah, okay.
But it's simply just remember a. If it's positive, infinity, negative, negative.
Okay. Perfect.
So finite geometrics, probably the trickiest one, because it has the most parts. But it's real similar to the infinite one, just a little bit more to it. So the equation is a times 1 minus r to the n over 1 minus r.
Okay.
So you already know what a is, you
Yeah.
already know what r is, and n, that's just the number of terms.
Yeah.
So remember from arithmetic finite?
Yeah.
Number of terms top, bottom one minus the top plus 1.
Yes.
So you just do that, and then you put in the first value times 1 minus the multiplier to the number of terms divided by 1 minus the multiplier.
So I can do this with a calculator, right? 'Cause
Oh, yeah.
Yeah. Okay. Okay.
And you just, for these, you just really need to remember those equations, and you'll be all set.
Oh. Okay. That sounds perfect, man. Thank you.
No problem.
Yeah, easy as pie, right?
Yeah.
Stanford. Yeah. You're a smart guy. Hey, what's up, bro?
What's up, man?
Hey, thanks for all your help. I passed the test. I can play.
Hey, here we go. Let's go.
State time.
State time. Here we go. Let's go.
So I hear we got a difficult case to solve here, the crime of trig identities. We've got sine, cosine, tangent, and we got the suspected witnesses, which is sigma 1, arcsine, unit circle. What do you got? What do you got, officer?
Well, we got the crooked sigma in, right? He told us it was cosine. I think he's lying.
Well, I think it was sine.
You think it was sine? That's what the exclamation point thought too. I forgot what its actual name was, but
Well, it seems we're having trouble with this case, so I think we need to call in a professional. I know just the guy.
you do?
I do.
Oh.
Let's do this.
All right.
Hello? Is this you bloody Americans again? What do you want this time? Oh, for God's sakes, do I have to solve another one of your crimes? God bless it, I'll be right there.
Wonder what he's gonna get here.
I have arrived, you intellectual embarrassment.
Why are you calling me an intellectual embarrassment when I need you here?
Did you drag me all the way across the pond to solve a trig identity?
Yes.
Are you kidding me? What in God's name?
Well, you see, it's because we got suspect 1 here, we got suspect 2 here, we got suspect 3 here, we got witnesses all over the place, and I don't know what to do. You're the guy.
Put down the donuts and give me that, you liberty lover. Get over here, I'm not done with you.
What?
You got this all wrong.
What are you talking about?
Suspect 1, negative sign of X. It wasn't sign of X. It was negative sign over X over witness 1. With that in mind, we can safely conclude that they multiplied by suspect 1 sign of X, top and bottom. It is known that witness 1 was going away from sine squared all over suspect 1 sine of X.
So, Sherlock, I'm seeing all this evidence here, but I'm not really seeing an ending to this case. Can you crack this case? 'Cause that's what I called you for. I didn't call you to give me evidence that I already have. Can you crack this case?
What are you talking about? I already did crack this case. Witness 1, take away sine squared of X over suspect 1 sine of X. Now go arrest him. What are you doing?
Calling in some backup. We got our suspect found here.
Case solved. Oh dear God. Get back here, we got it all wrong!
What is it? What is it? What do you got for me, Sherlock? You got more mindless babbling about evidence? Or do you actually solve this case?
Oh, just shut up and listen for a second. It was not witness 1 take away sine squared of X over suspect 1 sine X. The reason is that 1 and negative sine squared of X work together, therefore resulting in suspect's 2 alibi cosine squared of X. It was in fact cosine squared of X over suspect 1 sine of X.
You're brilliant, Sherlock. You cracked the case.